In 1912, Philip Franklin was in charge of the White Star Line shipping office, which oversaw the Titanic. Upon hearing reports of the ship striking an iceberg, he is quoted as saying, "We are absolutely satisfied that even if she was in a collision with an iceberg, she is in no danger. With her numerous watertight compartments, she is absolutely unsinkable, and it makes no difference what she hit." Now that phrase was said at the same time as 1,500 people were likely already dead. Before they were rescued, before there were people being survivors, they were probably about 1,500 dead at the time of him saying that. That is a fateful quote. And when we think about leadership speaking to tragedy and to failures of the Titanic, I think it's a perfect parallel for our Taproot podcast topic this week. I'm joined by Justin and Ken, and we're going to be talking about OceanGate. And I think this is a really important cultural conversation because the OceanGate story has a lot of elements of what we would call non-conservative decision-making. They would have called this the explorer mindset. That was their cultural term, the explorer mindset. So it's fitting that I've got my two naval submarine workers in here coming in with their experience. We recently just watched the Discovery's documentary on this tragedy. What were your guys' kind of initial feelings and takeaways?
Yeah. Well, first, I'll back up a little bit. Anytime I hear of a submarine issue, it kind of hits you home really quick. And from the Kursk when that went down, I remember vividly the feelings I had when the Kursk and the whole rescue operation was in place there. And the same with this. When I first heard that you have that visceral feeling on it because you can kind of picture the way it happens, those kinds of things, or the way in your mind you think it might be happening. So first, that's one of those from the gut kind of things, and when you hear about these kind of issues, that's my initial thoughts on that.
Yep, definitely pretty silent and sobering because I've been in that exact place before. Not 3,300 meters down, but far enough down that there's not a whole bunch that you're going to be able to do if something does go wrong.
Yeah, the Titanic is about 12,000 feet down. They were probably around 5,000 feet when the OceanGate Titan II sub failed. So definitely not a recoverable position, not a position you want to be in. Now, when I was watching this documentary, a couple things struck me. And when I look at the timeline of testing and preparation, to me, it very much, I was paralleling thinking about the nuclear Navy story of their pioneering innovation and pushing forward in an uncertain future. And I think this is a really interesting comparison when you think of, OceanGates was really pushing, we've got an innovative design. We're using new materials that are going to provide these new opportunities for people to see the sea floor, right? That's we're pioneers. And I think back to kind of my look at the Rickover story and the birth of the nuclear Navy. Again, now they had submarines, but they had never piloted a nuclear submarine where you have this high-risk situation with people in a tight metal tube underwater. There's a level of, I think maybe adventure is maybe not the right word, but of frontierism that comes from this. Yeah, and it's a very American maybe way of thinking of it because it's kind of our approach with things. But I think it's important because we're going to see more of these things in the future as we try to go to Mars or we try to go to the depths of the ocean, both places that few have been, and going back to the moon. All of these things are going to take a level of risk.
And if you don't forget that, I mean, when we first started doing a lot of different things in history, I don't want to say deaths were acceptable, but there was risk, and risk of death was in your head a little bit. You know, when the first guys went up Everest, you know, not everybody made it, and yet people keep going. So there's these kind of risks that you have to kind of take into account. Whether you got to think to yourself, though, am I an explorer or am I a commercial operator? And I think that's where this kind of got mixed together. If you're an explorer and you just want to go do stuff like that, hey, have at it. Once you start paying customers, you're in a completely different area now at this point, and your thought process should shift a little bit. And that's one of the things I took away from this, is I don't think that thought process shifted from that.
So I want to give kind of a rundown and get your guys' take. There was a couple things that stood out to me in this documentary, and they talked about some of the tests. So as you go across the years, there were different tests being done. They had 47 tests they did in the Bahamas on Titan 1. So Titan 1, they were doing these tests down in the Bahamas, and things were going good. They were getting depth. They went down to the Titanic level of depth. But it talks about this first test, test 47. This is when they experienced the crack. And they experienced that crack on their way up. And I think people don't understand a little bit material science. That's my background. When we think about carbon fiber and it as a structural material, it's not like steel. This isn't where you have materials that can deform, that are they're gonna have a very not elastic property to them. This is a composite material. It's layers. It's similar to, if you think your shirt, right, the knitting together of things. These have to be structured in a way. They don't fail slowly. They fail catastrophically.
Well, like fiberglass. If more people are familiar, I think, with fiberglass than carbon fiber, but it's a similar process with layers and binders that hold this stuff together.
Yeah. And so the idea of, you know, when you're at any type of pressure depth, a crack is not a small thing. And they go through this process. They come up, they find out they have a crack that runs the length of the ship. Maybe not the entire length, but it is a significant
length of the pressure hole.
It pretty much was, yeah.
And that, to me, would be a sobering wake-up call. And it was to the chief engineer. The chief engineer is let go because of this.
Because he pretty much said no more.
He said, this isn't going to work. You know, and I think I wouldn't call that the first non-conservative decision, because it certainly isn't, at least when I look at the history of it. But that certainly would be, if we were counting them, that's a pretty big one. Mm-hmm. The fact that you've got we're supposed to be doing a test and you have a failed test.
You call it a failure. That's exactly what it is.
When you have to replace the hull, that is a failure. Right. It's not a failure that you died in, but it is a failure.
I think they also, kind of in a conservative way, non-conservative way here, they never got their thinking in the same direction away from steel. So they were thinking to themselves that I think in the back of their minds, it's not explicitly said, but that it's going to fail gradually like a piece of steel. It flexes and you start seeing deformities and things like that. Mm-hmm. And even after the crack showed, they never really seemed to get out of the mindset that, we'll be able to catch it if it does start to fail. And carbon fiber doesn't do that.
We already have this major failure that we know about, but we're going to keep going, continuing on in that. But yeah, carbon fiber is very, very different than carbon steel. Let's say you have a 1-foot crack on a full-size carbon steel hull submarine, and you take that down 100 feet. The pressure is going to compress the hull and close that crack. I don't know if it'll do that with carbon fiber, but that's one of the reasons why we use carbon steel, is because this really large hole will close once you get under sea pressure. You come back up the top and realize, there's a hole there, and we properly take care of that, even on carbon steel holes, before we ever go back out.
So something to think about with this: when you've got a pressurized vessel, and it's going down, you're talking about this building pressure on the outside. It's pushing it together. When you come back up, what is happening?
The expansion.
It's releasing that pressure. Yeah.
So that's not just the outside of it. That's the entire thing is shifting. It's not a small amount of movement.
So I would imagine on this vessel, if on a submarine we used to tie a string across the hull, and as you submerge, you can watch that string come down as the hull compresses, and it gets smaller as it goes down, and the string gets loose. I would imagine on this carbon fiber, it doesn't do that. It just stays there because there is no flex anywhere in a carbon fiber vessel, not to the extent of a steel vessel.
And it's not entirely carbon fiber either. So there's this cap, and this cap is titanium. So you not only have one carbon fiber tube, you have a titanium. And
it probably is flexing.
They're all going to be flexing in some capacity, but they're going to be differently flexing. So they're going to have different elasticities, different compression and tension characteristics. And so those are going to be butted against each other. Those are going to be pushing or pulling
and moving.
Moving on each other. And so those all can add up in different ways.
And these can, by the way, all be compensated for. These can all be engineered. So it's not like this was a completely stupid, unworkable design. Now, I do want to mention, I don't know if I've ever seen, I talked earlier, I don't know if I've ever seen carbon fiber used in a compressive mode like this. Normally it's in a tensile mode where it's preventing expansion. Carbon overwrap pressure vessels, COPVs, are high pressure vessels. That's a thin piece of aluminum, and then they wrap it with carbon fiber, and it keeps it from expanding when you put pressure in. I don't know if I've ever seen a vessel where it's expected that the carbon fiber is going to be compressed and hold shape. It's usually the other way. Obviously, it can be done. They were down pretty deep, so it obviously works.
They made
to some
it to the
extent.
Titanic, at least.
Right. So it kind of works. I don't know if that's the best solution for carbon fiber.
So we've got a new material, and if you're taking a conservative approach, and I want to define this for a second because I think this is an important concept when we talk about what decisions are being made. So I did a summit talk on conservative decision-making. I know Mark has one this year at the summit, and the concept is looking at cross-purposes. So in cross purposes, the idea is that one of the major influences that causes accidents is senior management having a cross purpose. They see quarterly earnings separate from safety, quality, and reliability. The result is people become focused. They get too focused on cost cutting and meetings, and in this case, I think you'd argue selling the idea and the innovation of it. To really take a second and look at the safety shortcuts that lead to accidents. So, this CEO Stockton, he's looking at what is his goal. I want to have the company that's exploring the Titanic, and I want to go down there and be known for this. And this is like there's a prestige, there's money riding on it, right? He's got a company, there's debt that he's collected on these things. And so you've got to make it down there. And you only have so much to spend to do this. So there's this, are we compromising safety for it? So IMPO defines conservative decision-making as reaching conclusions by placing greater value on reactor safety above the production goals of the station. Decisions demonstrate recognition and avoidance of activities that unnecessarily reduce nuclear safety. So IMPO is looking at nuclear safety. Replace that with any kind of safety, and in this case we'd say hull integrity would probably be your top, and just as a sub-vessel you'd want hull integrity.
Certainly. That's step one.
So placing a greater value on hull integrity above mission and getting to the Titanic, right? What would you rather have? I'd rather make it back. So erring on the side of safety is what we would want people to do. So let's take a look at some of the testing decisions that were made, and you guys tell me, do you think this matches that conservative decision or not? So one of the things they got to talk through, they had Discovery Exploration Unknown came and was starting to film a documentary on the Titan submersible. And when they were doing a walk around, they got to see some of the tests, some of the test failures.
Subscale testing they did. So they had a small subscale piece of the hull,
third scale, yeah.
Yep, and they put them under pressure to see what happened.
And their goal was to find where it failed. That was their goal, right? That's what they said. We're going to run it until it fails, and we're going to look at these cracks and noise and vibration. So we're going to install these vibration and noise sensors around the sub, and we can listen for these cracks.
And we'll know where it's going to fail. See if we can figure out where that's going to be.
And we know how bad the failure is, and we'll know when it's ready to replace because we'll have this noise. Now, would you say that's a good safety feature to have some way of tracking your hull integrity?
Yes,
Absolutely.
I think that's a great. Yes, that's a great thing to have. On the flip side of that, this is a brand new piece of equipment with no prior external industry practice to fall back on. So they are innovating this on the fly as they're doing this. So it's a great system to have in place. It's got to be a well-developed system at some point in time before you decide to depend on it.
So you've nailed something important, I think. You've got innovative system. We're trying to push the bounds of. We're in uncharted waters.
It's a cool idea,
right? So new material in uncharted waters. Do you think you would take a conservative safety factor or a riskier safety factor?
Got to be conservative at that point. It's brand new.
Meaning, if I'm going to do this and I get to a certain threshold, I have to stop, and I have to set a clear threshold for this. This is not it was sort of this kind of sound. So you'd think those early tests, and you look at the failure point, and it's this big crack all the way along the side of it, and you're starting to see, like, oh, is this a consistent sign of how this is going to fail? So you hear that. I look at those old tests, big crack along the side of it. Yeah. You hear test 47, big crack all the way along the side of it. I mean, I'm not even seeing all the data, but then you already can start to see this as this is a failure mode. This is how it's going to fail if it fails. So they do these tests. They've got a sensor that's giving you data telling you when to stop. So they do test 47. They get that noise. They stop the test, and they fail out 47. Say, okay, we're going to go now and build Titan 2. Second one, new hull. Do they make a change?
So we think it's not clear in the documentary, so I'm not sure. It sounds like that they incorporated some lessons learned into it, but I wasn't clear what was changed. So I think so, but I don't know what they changed.
I don't think, and this is from mine, I did not see in my research that there was any major, and I would say this from an engineering standpoint of like, any structurally different change.
Right. I can't tell either. Did they wrap it differently? Did they use a different fiber?
They didn't change things like thickness. They didn't change things like so to me it's like maybe they processed it better. Maybe they did some things to innovate the process and make it maybe have less inclusions,
less voids and stuff.
Less voids. You can have those kind of things, but I think this is with a grain of salt, an opinion, not a fact, but I think it's probably evident that they believed that these were normal things to happen. The noise of it popping and creaking, and they decided that was an acceptable level of risk.
Yeah, I'd like to also, as long as we're talking about culture here a little bit, who the they is, as we're talking about this.
That's a good point.
The they was not necessarily the entire company who decided that these are okay. They had a CEO who was a hard-driving, hugely charismatic, I'm going to go do this, and he got his people all excited and going, most of them. And that kind of leadership has its place in innovation and entrepreneurial, explore mindset. But it has to be tempered sometimes with the right person to ensure that we're not overstepping some things here. So when we say that they didn't do any changes or they thought this, I think a lot of the they was him.
And you can see that in the emails because they had the chief engineer. They also had on that Dive 47, that first crack one, they had a external sub pilot who was down there with them, and he had a chain of emails back and forth. And so, I mean, when you've got two experts in yours saying, I wouldn't do this, this is bad, and we can't use this hull, I think this design isn't going to work. You have two people in there off of one test, and you decide to continue on. If you ever saw Monty Python and the Holy Grail, there's a scene with this the king in the castle, and he goes and he says, you know, they called me daft for trying to build a castle in a swamp, so I built it anyway, and the first one sank into the ground. And so I built another, and it sank into the ground as well. And I built a third, and it burned to the ground, fell over, and then sank into the swamp. Right? That's the way I see this kind of. If you look at, we did our tests and it cracked along this edge, and we ran this test down in the sub and it cracked along this edge, and we had this other test later the next year and we heard a loud crack. Yeah. It's the idea of hope is very counterintuitive in this. You're just hoping that it works out. And again, we push to that Rickover. Rickover has a famous quote for facing the facts, and it says, to resist the human inclination to hope that things will work out despite evidence or suspicions to the contrary. I think that's clear in this case. There is evidence of failure again and again, and they just got lucky 1, 2, maybe even 3 times in here.
And the critical piece there is that what they did with those failures was not design it out of the system and properly account for it, is that they just kept going doing exactly the same thing that they started with. And so even back to Rickover, that same principle of, hey, there is a major problem here that we need to deal with. Everybody else, all of his engineers and the rest of his Rickover's team was telling him, hey, it's probably going to be okay. Let's just take it out to sea trials and there's not going to be any issues.
The issues won't be long term, not short.
Yeah, we're not even sure that this mistake even happened. We're not even sure that the wrong quality of steel was installed at these points. And Rickover's answer was completely different than Stockton's. It was, no, we're not sure about the quality of this piping. Tear it all out, delay the operations, and put in the right stuff for sure, making that we sure test that it is the right quality and that we have the documentation and everything on it, because this cannot fail. That's a conservative decision. Delaying that operation so that we know nothing catastrophic is going to happen, even way down the road.
We've designed out a possible failure, and that's what they did at that point.
Now, the kind of the two things that are similar here is both Stockton and Rickover believed in everything that they did. Rickover believed in all of his engineering, and Stockton believed in all of his engineering, and they both put themselves on the submarines during the sea trials and the tests. So it's not, there's that similarity, but that's pretty much where the similarity ends. Rickover's response to any kind of quality defect was stop everything until you get it corrected. Stockton's was, let's keep moving forward, and it's probably not going to be an issue. We may or may not change anything in the design, but this is normal when we go explore things, rather than, no, we're in new territory and we need to make extra sure times 6 that everything is good to go.
So I think back to the video as well, where you have Discovery Channel is there, they're filming your stuff, they go into the submarine to kind of do a test and show them what it's like, and you watch this footage of it just going so badly. No, this isn't working, that's not working. This isn't working, the radio's not working. It's like there is thing after thing going wrong in front of a TV camera, and that's not a wake-up call to the CEO. That is not a wake-up call to him. That's normal. And I think this back to the Challenger disaster, and we think of like when things become normal, when failure, that case for Challenger, and we've talked about it in the past on the podcast, but you have these O-rings and they're not failing, but they are wearing more than expected on a normal launch. And now we get into an abnormal condition where it's cold and you're putting things through more stress than you had intended. And instead of stopping and going, hey, why are these experiencing more than I intended? You just say, no, it's okay. They survived the last time.
They didn't fail.
They didn't fail.
They must be okay.
It must be okay. They're worn more than we expected.
They're a little hot, look a little burned, but they'll be okay.
They look a little bit taking it. They're not doing so well, but they survived, so we're okay. And so I think there's a difference in, like you said, the Rickover approach to, no, it needs to be right for us to do this, versus it failed, but we were okay. We survived.
Yeah, we didn't die this time, so we're going to use that same piece of equipment another 8 times. 8th time.
And you can compare this to things like the SpaceX. SpaceX is launching, and they have successes and they have failures, and any failure is very media covered, but to them, they're doing tests to learn. And I saw a picture recently, and it was showing the difference between their rocket booster that was like the first gen and the current gen, and it's like just the changes that get made.
One of the things that was tough for SpaceX was NASA doesn't like things to change in between, and SpaceX changes almost every flight. They make little tweaks and mods to make it better and get it better, and there was a problem that could have happened. They engineer it out. Those are the kinds of things that you want to happen. It was kind of a culture shift at NASA to allow those kinds of things to happen, because that's just not how you do things. You design it, and then if it works, you don't touch that. It's working. Don't touch it. And SpaceX has a much different philosophy about continuous improvement on stuff. Yeah.
And so I think that's a very different. You can still be innovative and make conservative decisions.
Yes.
I remember one of the CEOs that was in my talk when I talked about this. He said that was his biggest takeaway, was the mindset, because what Rickover was doing was innovative. And it wasn't low risk. This is nuclear. You're taking a nuclear process that we were using to, bomb people a decade before, and we're doing bomb tests and things. And now we're going to make a reactor, and we're going to make it small, and we're going to stick people around it.
And we're going to shoot at it other countries are going to shoot at it. Yeah. It'll all be fine.
It'll all be fine. Like that's the cutting edge of what the technology was, and so that you can be innovative and be the first and push the envelope, but still do it in a way where you're not taking risks that are putting the lives of your people at risk and putting your lives of it doesn't have to conflict with your ultimate goal, right, with your ultimate mission for your company. So I think another one that was interesting with this, when we talk about like the failures that led up to this, there was another one called Dive 62. And in the reporting of this Dive 62 got diverted. It was originally going to go, but the front falls off. The front falls off the sub.
Classic.
Yeah, you're thinking of the Australian foot come off.
Into the environment.
Into the environment. No, it was pulled into the environment. We took it from the environment to a new environment. So the front fell off. And they talk about, it has 4 bolts. So you could put 18, but we only put 4 bolts on there because the sub pressure is going to hold the front on. And again, that ties back to what you're talking about. It gets so tight down there. They have this front fall off, and they're like, okay, well, let's stop. We got to go back, fix things. Don't take any pictures of this. Delete all these pictures. We don't want bad press on this. And then they go down on Dive 62. Dive 62, they can't make it down to the Titanic. They don't make it down there. They have to come back up, and they have 10 dive critical failures. Now, I can't name all 10 of them off the top of my head. There was valves that were left open. There were systems that didn't work. There were battery banks that didn't work. And you're like, we have the front fall off, and now we have 10 critical failures. Let's go down again after that. And they keep doing these things. They'll do another test, another dive. They make it down there. They make it down to the Titanic, and they get beautiful footage. And they get to see a lot of the changes that have happened in the Titanic since the last time there was footage. For them, big success, right? We've made it down there in the Titan.
Yep.
They come back up, and during Dive 80, on the ascent, they hear a big noise. And they have to stop when they get up there, and there's conversations about was there delamination? Did something happen? And they decide to stop. and they do a few more dives right after this, but they make a stop and they have an announcement about, there's lots of concerns about things, but everything's good, right? And there's people in there that got fired, that got let go because of that, and because they were raising concerns, and by raising concerns, they didn't have an explorer mindset.
Yep. Yep.
Like, that's a culture push to me. I think, again, is it a conservative decision-making? You've now had a major noise. That's the same thing that happened on dive 47, a big, loud crack. So we talked earlier. What was their safety system that was supposed to help them with this?
The sound monitoring system that they had in place.
And so if you were making decisions, what would you look at?
That's the first thing you take. I wonder what we saw on there, right? What did that show?
And when the documentary shows that graph, and it's just like, there's a ping right there. And you're like, why have this system if you're not going to listen to it?
Right. In fact, that was a big selling point for it. It was right on their website. We have this innovative to make it. It makes it so safe. Look at this. I can't remember the name of it now, but their failure monitoring system, their microphones. This is what makes it so safe. And then they don't use it. They don't refer to it. They don't go look at it. They don't listen to it.
It'll tell me right before it's going to fail. It'll give me all the indications leading up to failure, and they had all those indications leading up to failure, and they did nothing about it.
And not only did they do nothing, you've got a piece of equipment that now is probably compromised. And what do? We put it up wet and leave it outside.
So that was so glossed over a little bit during the documentary, where they put it up wet. Where was it, Massachusetts, if I remember right? Is that where it was?
I thought it was still in St. John's, but yeah.
Maybe St. John's.
That's where they were headed.
They put it up on the pier and they left it there over the winter. And their engineer was like, you can't do that. You can't leave wet carbon fiber to freeze. It's going to snap all those fibers in there. And they did it anyway. It seemed like that was kind of glossed over during the documentary, but to me that was why don't we just hit it with a hammer a few times before we take it.
I think of we're down here in the South in Tennessee, and there's a reputation for any car that's been through a winter up north, right?
Yeah.
Because the salt and the cold and all those are just rust buckets from the north, right? I can't imagine going, well, it's bad for cars, but it's okay for submarines to be up north in the winter.
Yeah.
So to me, it's very much we just take, it cracked, but it's okay. It'll sit outside in the winter. Your windshield won't sit outside in the winter with a crack in it, right. In the north. So it's like there's just decision after decision, and it results on the last dive on June 18th in 2023 with them down at around 1,600 meters, 5,000 feet in that range. They drop 2 weights and they're gone and never heard from again. Mm-hmm. And the last thing to me was powerful, and I don't know how true what that noise was.
That's probably accurate.
They have that recording of them hearing a noise and immediately going, what does it say on the computer? Dropped 2 weights. Mm-hmm. Likely was them hearing the sound of it crushing.
Yep. That's probably there's been several submarine accidents where in hindsight they go back and listen to the hydrophones from thousands of miles away sometimes, and there it is. It's if you listen to the Thresher, Thresher has one of those. That's eerie, hearing that thing going and collapsing. So yeah.
So to me, it resulted in and people have said this is an obvious conclusion to this, and I think if you look at the history of failure, it was gonna fail. It was gonna be this failure point, and it propagates starting at that titanium joining spot to the carbon fiber. It's gonna be a weak point. It's part of the design that it's gonna be a weak point. So if you're gonna do this, you have to design around that. And they saw the signs again and again of this failure, and I think they never steered away from it.
Yeah. Well, they blinded themselves to it. It's at least him. When I say they again, it's mainly him. But and it was, I mean, there's more than just him. Obviously, there were others that had to continue to prep the submersible. They had to get supplies for it. So there's others there that are aware and still allowed themselves to be blinded. And by him saying it's fine, they said, okay, he knows what he's doing, it's fine.
So to me, one of the bigger, maybe most damning testimony was, and I forget her name, but she was the robotics engineer for autonomous. That's what her background was. And she was one of the people that was let go after the crack that occurred because she was reporting this, I think it delaminated. She was doing what we call employee feedback, which is, hey, this does not sound safe. This does not seem safe to me. I don't think we should be continuing this. I think we need to go back and look at this to see if it's cracked. So, we talk about the two-way street, right? Leadership is communicating values, and employees are saying when things don't match those values. And Stockton talked about safety a lot.
He did.
There was video evidence of him saying we want to be safe. We're taking great risks, but we're doing what we can to make sure and ensure things are safe. So he's trying to promote that we are doing things safe. But when somebody brings a concern of, hey, this doesn't match what you say you care about,
right.
Not only did he dismiss it, but in the story she talked about talking to her superior, and her superior was questioning. She comes to her superior and says, I have questions. And she goes, oh, people have questions about you too. And your commitment, your explorer mindset. Yeah. And I think that is a cultural sign and a clear signal of bad communication, because what you're saying and reality behind what you're promoting do not match. And when employees are giving you feedback that things do not match what you say is important,
and you blow that off,
you're blowing it off. You're not making those conservative decisions. You're telling them, let's take more risks.
And they're not going to report anything else at that point.
Yeah,
they're done making reports, right? Well, if I just say I think we're all going to die and they just blew me off, I'm probably not going to tell them anything else from this point.
They were okayed again and again with this piece of equipment failed and this piece of equipment had a problem. But hey, we made it to the surface, so it's okay.
It's all good.
It's okay that it failed when you're hundreds of feet, thousands of feet below the surface. There's no getting back. Right. Again, you're sealed into this thing. The front is bolted on.
Yeah. There's no escape hatch on this thing.
Yeah, this is not. And where are you going to go?
Yep.
Where are you going to go?
Yep.
So I think this is a clear evidence of the decisions and how they add up. There's definitely evidence here of, we'll say, malpractice and bad decisions. Whether that is something that you can litigate, whether that's criminal, I'm not going to be the one that can say that,
right.
But it's definitely preventable and foreseeable. Right. And so companies need to figure that out. They need to figure out how are they aligning their culture, what kinds of signals are they sending. I think this is an interesting topic, and it's one of the reasons why we have Gard Clark coming to speak about it at the summit. So he's going to be our Thursday morning speaker, and he's got life and death underwater. So he's going to be talking more about this case and really some of the other concerns about underwater vessels and safety and building in that mindset for proper work underwater.
And he's got a great perspective. He's a former submarine commander, so he's got it from the leadership side, from the management side, if you want to think of it that way, of how this would work. So really looking forward to hearing his perspective. We're just the peons down there running, right? But the commander up there, interesting to see how what his take is on this.
Yep. And he's been in the exact position, CEO of the submarine and the whole operation, directly responsible. So he has been in exactly Stockton's position before.
Right.
So it's a great opportunity. Check it out. Taproot Summit coming up this October. We always have really interesting, unique speakers, and I think this is going to be one of the highlight talks of the summit. So check it out and come to the Taproot Summit. You can see more information on our website, and make sure you subscribe and comment if you've got questions. And maybe we'll check out and see some questions for Gard.